This video is about graphing exponential functions and logarithmic functions. First, we will review the parent functions that we learned in Honors Algebra 2 Trig. For exponential functions, we have y equals 2 to the x and y equals e to the x shown on the screen. Both of them have domains from negative infinity to infinity, and the range is from 0 to infinity. Notice there is a horizontal asymptote at y equals 0 for both functions, and the defining points are basically defined by what happens when we substitute easy numbers like 0, 1, and 2 in for x. 2 to the 0 power is 1, 2 to the 1 power is 2, 2 to the second power is 4. For e to the x, it's the same thing. E to the first power is e to the second power is e squared, and of course e to the 0 is 1 because any constant number down here to the 0 power is 1 with the exception of 0. 0 to the 0 is something we don't really want to deal with at the moment. Now we will expect you to be able to do e to the x without a calculator, and so in order to understand that, we just approximate e on our graph as 2.7 or so, and e squared is 7.4. So essentially what you have to do is put a dot somewhere between 2 and 3 and put a point somewhere between 7 and 8 as you're graphing it. So it shouldn't be that difficult. The key characteristics of exponential functions are that they have a horizontal asymptote. They don't have a vertical asymptote. They have an unlimited domain and they have a limited range. So the range is bounded by the horizontal asymptote. So notice in this problem and in this problem, the range is 0 to infinity, but the domain is unlimited. For log functions, these are the inverse functions of exponential functions. So what you'll notice is that all of the points that are the defining points of log base 2 of x and natural log of x are just the inverse points of the exponential graphs that we had for 2 to the x and e to the x. So all the x and y values just flip here. Also notice that means that the asymptote is now a vertical asymptote instead of a horizontal asymptote. And notice that now the domain has a restriction. The domains are now 0 to infinity, and the ranges are unlimited. So notice that these are just the inverse functions when compared to 2 to the x and e to the x. For key characteristics, logarithmic functions have a vertical asymptote. They don't have a horizontal asymptote. They have a limited domain that's bounded by the vertical asymptote. They have an unlimited range, and they have the property of being the inverse function of an exponential function. So if you wanted, you could write that these are inverses of log functions as well. I was just extending the drama by not putting it up here because we hadn't talked about logs yet. So also notice log base 2 of 4 is 2, and that's something that we'll talk about a little bit more later in the unit. So now let's do some examples. Y equals 2 to the x minus 1 plus 3. So what we may notice is that in this function, we have a right shift of 1 and a downshift of 3. So what that's going to do is it's going to take our 2 to the x graph. It's going to move it right 1 and down 3. This number in exponential graphs will also represent the equation of the asymptote, because notice that the asymptote was y equals 0. Now it's getting shifted down 3. So that represents the equation of the asymptote. The domain is always unlimited We have no restrictions on what's happening in an exponential function when we substitute an x. The range is going to be moved down 3. So we have -3 to infinity. Notice it's bounded by the asymptote. And then if we want to figure out what happens to each point, we take the x and move it up 1. We take the y and we move it down 3. So I should graph -1, -2, 2, I'm sorry, 1, couldn't read, 1, -2, 2, -1, and 3, 1. If I wanted to graph another point, I could. So 3, 8 would also get moved right 1 and down 3. So that would be 4, 5. And then I graph it going toward the horizontal asymptote, then go up. So there's a graph of that. Number 2, -3 to the x plus 2. The negative is not in parentheses, so that means that the 3 to the x is kind of operating separately. And then the negative is kind of a vertical reflection of this graph. So my y's are getting multiplied by -1. My x's have nothing happening to them. And then my y's get added by 2. So once again, the domain, -infinity to infinity. I'll figure out the equation of the asymptote. So normally it's at 0. I'm going to multiply it by -1. 0 times -1 is still 0. Then I add 2. Now, since this is a vertical reflection, my graph is going to be going down in some way. So we'll talk about that as we move along. The equation of the asymptote is y equals 2. And since the graph is going down, my range will actually be -infinity to 2. Next thing we need to talk about is, since this is 3 to the x, notice my points are 0, 1, 1, 3, and 2, 9. Notice that the y values are not the same as they were over here, because 3 to the 1 is 3, and 3 squared is 9. So now I'll transform all the points. All my x's remain the same. My y's get multiplied by -1 and then add 2. So -1 plus 2, -3 plus 2, and -9 plus 2. So I end up at 0, 1, 1, -1, and 2, -7. And it looks something like this. And that's going down a little steep, but it's hard to draw on the tablet. Now we have some log functions. So in here, we have x's moving down 3, y's moving up 1. Remember that the range of any log function is unlimited. The domain is going to be bounded by the horizontal or the vertical asymptote. Notice that the vertical asymptote was an x equals thing. So my vertical asymptote will be what happens when the inside of this is equal to 0. So the inside of this will be equal to 0 at -3, which makes sense since my graph is shifting left 3. So the domain of this graph is -3 to infinity. And the equation of my asymptote is x equals -3. I don't know why I just wrote the x like that. Now I'm going to transform all my points. So all my x's get moved left 3. All my y's get moved up 1. So I have a point at -2, 1, -1, 2, and 1, 3. If I took 8, 3 and moved that, that would move to 5, 4. And what I may notice about this is that my transformed points in number 1 and number 3 are actually inverses of each other. That's because if I find the inverse function of number 1 and I change the x and y's and then solve for y, I get rid of 2 to a power by taking the natural log of 2, or not natural log of 2, log base 2 of both sides. And then if I add 1 to both sides, I get y equals log base 2 of x minus 3 minus 1. So notice that if I actually solve this using the inverse function method, I would get the same thing. Let's see if that happens for number 4. And it seems like that may work because I have a negative 3 to the x and a plus 2, and then I have a minus 2, so it seems like it might work. Let's just check the points. So the domain of this graph, we'll talk about that in a second. The range is always unlimited. What's happening is my x's are getting multiplied by negative 1, and my y's are getting subtracted by 2. So the domain of this graph is probably going to, since my x's are getting multiplied by negative 1, I'm going to have some kind of graph that goes this way. So my domain will be negative infinity to 0. The equation of the asymptote remains x equals 0 because multiplying 0 by anything doesn't change it, and there's no shifting. So now let's transform the points. If I multiply all of my x's by negative 1, then I shift my y's down 2, I end up at negative 1, negative 2, negative 3, negative 1, negative 9, 0. And what you'll notice is that these points are not flipping like they did in the previous problem. So 1 and 3 are inverses, but 2 and 4 are not. And notice what's happening. All the y stuff was moving here, but not everything was moving with an x. And if you see how we would change the x and y and solve for y to try and get an inverse function for this one, I'd multiply that by negative 1, so I'd have negative x minus 2 or 2 minus x equals 3 to the y. So y would equal log base 3 of negative x minus 2. So all of the shifting and stretching and stuff would be on the inside of the function. Lastly, let's do problems 5 and 6. So again, the domain of any exponential function is negative infinity to infinity. The range of any log function is negative infinity to infinity. The equation of the asymptote in number 5, there's a, well, I guess we should talk about what's happening. So the y's are getting multiplied by negative 1, then I add 3, so that's going to happen to my asymptote too. So 0 times negative 1 is still 0, plus 3 gives me an asymptote at y equals 3. The range, since I'm multiplying by negative 1, it's going to flip down. So I have negative infinity to 3. Then I'll transform my points. So my x's, nothing happens. My y's, I'm going to multiply by negative 1, then add 3. So I have negative e plus 3, negative e squared plus 3. Remember, e is like 2.7. So I have 0, 2. I have negative 2.7 plus 3, so that's somewhere between 0 and 1. And I have negative 7.4 plus 3, so that's like negative 4.4, somewhere between negative 4 and negative 5. So there's my graph. And then finally, 2 natural log of negative x, multiply the y's by 2, multiply the x's by negative 1. So my domain for x will be negative infinity to 0 because I'm multiplying it by negative 1, but my asymptote will not change. And then my transform points are negative 1, 0, negative e2, negative e squared 4. So if my asymptote is at x equals 0, and I have this horizontal reflection happening, negative 1, 0, negative e is like negative 2.7, and negative e squared is about negative 7.5. Comma 4. There's my log graph, which is growing kind of slow.